Let's start with creating a geonode and call it Fourier. Dive inside. I need to create some points, so I'll do it with wrangle in detail mode and call it create points. Okay, so I can create a channel, an integer channel, call it PTS for points. Apply and accept. And I want 10 points. Basically, I can reference this channel using vex, so I will do it with creating a variable PTS that is equal to channel integer called PTS, because this one is called PTS. Okay. So let's create a vector position equal to the origin 0, 0, 0. Okay. Alt E to make it a bit bigger. Let's make a for loop. With int I equal to 0, I is less than PTS, I plus plus. So I need to create the point, so int, I call it new PT is equal to add point function and geometry stream 0 position pos. Apply and accept. Okay, so I have now 10 points. Let's group these points, because then I'll connect them with a line. So group type is points and called initial points, maybe with a space, without a space, initial points. Okay, so now I have a group with 10 points. Let's make another wrangle, a point wrangle, and let's declare a float attribute called angle, and let's initialize it with 0. Okay, so now we have angle. Okay, so let's make a solver. Let's go solver reset. Okay, so here we have the 4 inputs, but what I need is the previous frame and the input 1. Let's make a wrangle in points mode, in points, and actually in the solver it's better to use always an output. So this is the end of the chain out. Let's open Alt E and let's make some code. So first of all, let's access the points we created. So for that I'll make total points, total PTS, it's equal to endpoints function from geometry 1, so they will come from this stream. Then let's create a position, a vector pose, and then let's dot points vector position. Well, now I have to move these points based on a radius, so I will declare a float radius equal to 1 for the moment. And then I can create the pose using the polar to Cartesian coordinates. We have the position x, it's let's say plus equal to the radius multiply the cosine of the angle, and the angle is angle. Copy paste. I can create the y position, but this time with the sine function. Okay. For the points to move in the circle, I need to increment the angle. So I'll say at angle it's plus equals an amount that for me it's 0.25, and I can write these values now to the point position. So at P is equal to set position dot x position dot y, and there is no position in the z value, so I'll set it to 0. If I say apply and accept, I have to, this is an attribute, so I need to refer it as with the at. So if I go up and I pin this view here, I'll see that they move in a circular way. Okay, but they all move because they all have the same radius and the same properties. So for them to move in a different way, I have to change a few values. So let's create a float called n, and then by the way, if now they are moving counterclockwise, if I change this, if I change in minus, reset, they will move the same way. No, I have to change the angle. The angle is minus, reset it. Reset. Why this is doing this? Minus, minus, reset. Okay, there's some display issues. All right, so let's create a for loop. And let's iterate through the point number. So int I is equal to 0. I is less than at ptnum I plus plus. I need to change this the radius, and also the let's not make the radius equal to 1, but let's modify this this value. So n will be equal to I multiply 2 times 1. And why this? Because if you see the formula, we have the I increments by 2. So basically I have for each point, if I is 0, this will be plus 1, it's here. I is 0, this will be 0, it will be 1. If I is 1, this will be 2 plus 1, 3. If I is 2, this will be 4 plus 1, 5. So increments by 2. Then we have to set the radius, that would be basically 2 times, and for this I'm following the formula, 4 divided by n multiplied by $pi. Right, and semicolon. At this point I can copy this, I can modify these values, and I'll say instead of this I'll say R is cosine of n times the angle, n times the angle. Okay, so as soon as I do this and I go up, you see that the point changes. Let's make maybe 7 points, maybe it's more visible. So now if I move, they have this motion. Okay, to see it better, let's make an add sub, and let's group by initial points. So okay, but the Fourier series, we have also this wave, and to do that we have to create an array of points. So we can do it here, Alt E. Let's make an array called a vector array called wave. Okay. But the array, the wave is based only on the top point. So I need to make an if statement. Like this. So if I is equal to the dot points -2, I want to push in the wave array the position .y. Okay. Apply and accept. So to access this array now, I need to create a wrangle, a pointer angle, call it show wave. And here I need to create a for loop. So here are the values. So let's iterate through this array with a for loop. So int I equal to 0, I is less than the length of the array, so v at wave and I++. Okay, so let's make a vector called position, and this one would be equal to set I and then v at wave I dot dot epsilon and 0. And let's add a new point on this position. So int pt is equal to add point. I have problems with the at geometry stream 0 position. Apply and accept. Let's see if it works. Okay. Here are the points. If we modify this I, let's multiply it by, let's say, channel, and call it amplitude. Channel float amplitude. Okay, let's say 0.2. Let's see what happens. Okay. As you see, I need to connect this point. I needed to reverse this array because now it's moving in that direction. So to do that, I can do it here. We'll say v at I call it resort is equal to reverse the wave. So v at wave. Now the array is resorted backwards. So I have to access here instead of wave. I call it resort, and also here resort. So let's see. Reset. Show wave, reset. I don't know why sometimes he's doing this. So v at resort is equal to reverse v at wave. Okay, up. Okay. Let's group these points. Let's make a new group. A group points and call it wave. And the group, it's we call this initial points. So let's copy this and let's say that it's not the initial points. Now with the transform, let's move it, the wave, like, I don't know, 3 units, maybe 5. Let's reset it. Okay. And let's make an add SOP, and let's by group, the group is wave, and now we have this. I would like to work more on this and add in some circles. So basically I am in this point. Let's do 7 points. Okay, here we have one primitive with 7 points. To add circles to these points, let's take let's append a SOP called convert line, and this now will give me 6 primitives. Not only that, but we'll create an attribute called rest length. Okay, so if we promote this attribute promote from primitive to point level, we have it now. So let's make a circle. NURBS open arc, and let's copy 2 points. Okay, but I would like that these circles follow the rest length attribute. So for that we have to stamp inputs and create an attribute and a variable called r, or radius, and this will be equal to rest length. Okay, so if I go now in the circle with stamp function, stamp copy 1, the attribute is called radius. Okay, so now, and then this we can sweep it with another circle and have the final movement. I already create this, and it's basically this. I think here I used like 7 points, but you can use how many you want, and basically you change it here. If I put 30 points, I'll have this. Okay, that's it. Thank you for watching.